Hello students, we are in second video of assignment 10.3. In first video we saw intensity of resultant wave when two incoherent waves superpose. In this video we'll discuss second question of this assignment. Write expression for intensity of resultant wave due to interference of two waves and using it obtain expression for intensity of wave due to interference of two coherent waves. So in previous case, the two waves which were being superposed were incoherent waves. Now we are talking about superposition of coherent waves. So let us first see the expression for intensity of resultant wave due to interference of two waves, and then we will see what happens if the two waves being superposed are coherent. What we are talking about is a situation where two waves coming from sources S1 and S2 are being superposed at a point P. S1 is at distance R1, S2 is at distance R2 from point P, and the two have distance D between them, and let the screen be placed at distance capital D. So this is the situation, and for this situation the intensity at point P can be given as I, which is equal to I1 plus I2 plus 2 root I1 I2 average of cos of delta 2 minus delta 1. What is delta 2? What is delta 1? Delta 2 and delta 1 are phases of first wave, second wave. And how do we find out average of cos delta? So average of cos delta can be found out by taking integration over one cycle of cos of omega 2 minus omega 1 t minus k2 r2 minus k1 r1 plus phi 2 minus phi 1 dt. Okay, now when you consider the sources to be coherent, you are saying that the sources are producing identical waves. What do you mean by identical waves? They have same frequency, so omega 1 omega 2 will be same and wavelength will also be same. Moreover, if I consider that phases are same, then phi will be phi 2 minus phi 1 will be constant, and for convenience we may take phi 2 minus phi 1 to be 0. You may take constant, it won't make much difference, except that you will have to carry on constant term in every mathematical step. So for convenience, we consider that phi 2 minus phi 1 is 0. And if omega 2 is equal to omega 1, we may consider this 2 as omega. And if lambdas are same, we don't need to write k1 and k2. Instead of the 2, we may simply mention k. So with this consideration, I should be able to write average of cos delta like this, 1 by t integration from 0 to t cos of, now I don't need to write omega 2 minus omega 1, that term will vanish, it will be 0 because both omegas are same. Here instead of k2 and k1, what I can write is k r2 minus r1. Okay, and again, as we are assuming phi 2 and phi 1 to be same, that term will also be reduced down to 0, and hence this is our cost term. Okay, but as k is constant, r2 r1 are also constant, so what I am talking about is cos k r2 minus r1 upon t integration dt. And what is the integration of dt? It will be t ultimately. So the integration will be simply cos k r2 minus r1. Let me substitute this result here. So what do we get? Okay, one more thing I forgot. That when you consider the sources to be coherent, at that time the waves are identical, and so we don't need to write even I1, I2. We can replace I1 and I2 with common symbol I0. Okay, so let us consider all these facts in this equation of intensity. And then what do I get? I get I is equal to, instead of I1, instead of this I1, I write I0. Instead of I2, I will write I0 because I'm talking about coherent waves, intensities are same. And I0 into I0 will give me I0 square. So that is again 2I0 with cos k R2 minus R1. Simplify this. What you will have? 2I0 1 plus k R2 minus R1. Now, sorry, I forgot cos term. 2I0 cos of k R2 minus R1. This is the intensity. Now, if you use a trigonometrical identity, you can simplify this bracket further. If you go back to your maths, you must have used this equation. Cos of 2 theta is 2 cos square theta minus 1. So make 2 cos square theta subject of formula. You'll have 1 plus cos 2 theta. Now compare this term with our square bracket. So this is our 2 theta term. Okay, this is 2 theta term. And then I can replace this 1 plus cos 2 theta with 2 cos square theta. So applying this formula, I get I to be 2I0. Okay, and then 2 cos square theta, 2 cos square. Remember, this term is 2 theta. I want cos square theta. So I'll take k r2 minus r1 by 2. Okay, and then the equation is I is equal to 4I0 cos square k r2 minus r1 by 2. This is the expression of intensity in case of two waves which are coherent in nature. Where R1, R2 both are paths, so R2 minus R1 is called path difference. R2 minus R1 is called path difference of two waves. And path difference is the key term in determining whether the interference will be constructive or destructive in nature, which we will see in next video. Thank you.